Okay, so we're going to be doing service entrance calculation for a commercial, for residential building. You can follow up with Chad and 220, Article 220. We're going to spend a lot of time in Article 220. My tabs are getting bad. It's a problem when you get used to the tabs. We're going to spend a lot of time, guys, in Article 220. Lots of times in Article 220. Okay, and do we guys have an extra copy of the load cal? Anybody has an extra copy of the load cal? Yeah, thank you. Okay, so my expectation, guys, everyone has a copy of this load calculation sheet that you see in front of you. We're going to convert it into Excel, and I can help you with Excel as we go through. I'm going to go calculate this based on the NEC code book. Here's the assumption. This calculation, guys, is based on the building that we have, the actual building that we have. This calculation is for the main service for the building. So we're doing the main service for the building. So we'll do the main service, and then you guys will do the rest. You will do the apartments. Okay, now, step number one, so load calculation, main service. Everybody knows the assumption. It's going to be a main service for the building. And we have step number one, my friends. Step number one with the calculation is we need to find the lighting. This is recorded as well as PDF'd. Everything is going to be PDF'd as that I'm going to be writing. So I have, when I calculated the square foot, the code says, first of all, why don't you guys go to table 220.12, page 59, 220.12. My assumption is this is not the first time that you have done load calculation, right? We did load calculation before, so it's not the first time. So when I say go to table 220.12, and from table 220.12, you guys are looking at it right in front of you. We can find that the square foot, the code gives a volt amp per square foot, for a residential building. This volt amp per square foot covers the following: all lighting and convenient receptacles. Only for residential, this table will cover convenient receptacles. Only for residential. When we use it for commercial later on, receptacles will be done separately. They're done on a separate calculation. Okay, so everybody went to table. This is table number 220.12. Do we have, as we go through, could you please check the articles, guys? I might have made a mistake over the years. So table 220.12. Everybody knows how to find the 3 volt amp per square foot. And what is this number here? What's this number? 488.5. This is the square foot of the building. Our building, guys, is 2-story building. So if you calculate the square foot outside perimeter of the first apartment and multiply it by 2, basically, square foot of the building, multiply it by 2, you should come up with close to this number. So what is this number here? This is the square foot of the residential building that we're dealing with. Everybody's okay with that? Cool? Okay. So if you do the calculation, I want to do the calculation here. So if you take 488.5 square foot of the building, multiply it by 3, I want somebody to verify the calculation, please. And you should come up with 1455 volt amp. 146. I should have looked at it, huh? So the calculation is right. I just want somebody to verify it. 14655 volt amp. Okay? And which is, you're looking at it right here. So yes, sir.
So you take the length times the width times 2.
Yep.
Okay.
You take the length times the width, find the area, multiply by 2. Any question, guys, about this step? Straightforward, right? When you do the apartment, what do you need to do then? You're going to go find the square foot of apartment 1 and do the same calculation for it. Apartment 2, apartment 3, apartment 4. And then what I would do, I choose the apartment that has the largest amp, and size all the other apartments based on it, because you don't want to, you're going to see that they're all going to be in the same size. And then I will use, now when we go to the common area, right, there's a common apartment, common panel or house panel. When we go to the house panel, take the area, listen to me carefully, take the area of the common areas, stairways, hallways, common stairways, utility room, what else? Common between them. That's it. Stairways, hallways, and utility room, which is common between all of them. And you put the square foot of this common panel here, and you do the same calculation. Any question about how to do this calculation for every apartment and for the common area? The only thing is going to change in this calculation is what? This number right here. This is looking at the whole building, the service for the whole building. The service for the whole building. Any question, guys? Okay, so no questions. Go to minimum number of lighting branch circuits. This is just calculation. We don't follow. It's kind of recommendation. It has nothing, that's why I put it in yellow. It has nothing to do with sizing the panel. It just gives you an idea, Spencer, is how many convenient 15 amp circuits you're expected to have in the whole apartment. Remember, just recommendation. You don't have to follow it. We did when we did our 15, how many lighting circuits or receptacle circuit we loaded the 15 based on, we put 9, right? We put 9 on the 15 amp circuit, 9 lighting receptacles, all lights. So this is recommendation. What did we do? We took this number here, right? We took the 104,655, divide this by 120, and that gave you 122 amp, which is this number here. And then you took the 122 amps divided by 15, and that will get you 9 circuits, which is exactly what you did. That's exactly what we did. You're going to do this in math in Excel. Everybody knows how to use Excel in math. If you don't, I will help you. No problem. So we came up with nine 15 amp circuits. Now, Ryan, my friend, if I want to use a 20 amp circuit, like my brother-in-law decided to wire his house at number 12, 20 amp circuits all, what do you do? What do you divide? The only difference here is what do you do with this? Divide by 20. I put this in yellow because it has nothing to do with calculating the load. This is just giving you an estimate. How many convenient circuits or general purpose receptacle circuits and lights you need in this building? Okay, so again, this has nothing to do with the calculation. Moving on, now continue with the calculation. This number has to do with the calculation of the load. I want to go back into, in residential building, the code says every apartment or every dwelling unit have to have 2 small appliances circuits, and you have to give it a dedicated 15 volt ampere square foot. You can find this one, and I want you guys to go to this article right in here. I verified this one. So this is 52A. Everybody's there? 52A, except the teacher is not there. 52A, small appliances circuits. If you read through it, Brad, all the way in the middle, it says 15 volt ampere square foot. So these 15 did not came from Chad's basement, came from right in here. Okay, so two small appliances circuits. Why? Now remember, I'm looking, Mr. Erbab, I'm looking at the whole building. So how many 2 small appliances circuit in the whole building? By code, 8. Why 8? 2 in each one. Everybody knows why I put the number 8, 2 in each apartment. So this number 8, 2 small appliances circuit in every apartment, multiplied by this number. So 8 times 1500 equal 12,000 volt amp. And which is you guys are looking at. Any question about that? Any question about why did we come up with, did you guys do the math? Come up the same? Everybody knows why 8. Now when you do the apartments, Jim, my friend, this number will be converted to what? 2. When you do the common panel, what do you think this number would be? Common panel, not the main panel,
0.
the house panel. 0, because do we have laundry, not laundry, do we have small appliances circuit for it? No, we don't. Does that make sense? So here's what to make it easier on you guys, you're going to develop one Excel sheet and then copy it 6 times, or copy it 5 times. And then the things that does not exist in that part calculation, just put 0. That's what I would do instead of creating 6 different sheets, one sheet that encompasses all of them, and then you start zeroing the thing that does not exist in each panel. For example, if I'm doing the house panel, this number would be what? 0. If I'm doing any other apartment panel, this number would be 2. Okay, so we're cool. So we move on. Laundry. The code says, I want you guys to verify this code too, make sure it's right. 220.52b, right underneath it. It says you have to, laundry circuit, you have to provide at least one laundry circuit for every dwelling unit. And based on laundry circuit for every dwelling unit, and based on, what did we say based this one on? Based on 1500 volt amp, 1500 volt amp. Now, how many laundry circuits do we, first of all, do we have laundry circuits? Have we provided laundry circuits in the apartments? There's no laundry circuit in the apartments. How many laundry circuits did we provide in the utility room? Did we have 4 or 2? We provided 2. We provided, in our example, we provided 2. So this number, cross this number, I'm going to have 2. So 2 times 1500 equal, I want to cross this number, equal what? 3000 volt amp. And that's the one I want to carry. Okay? Everybody corrected that one? If we provided another 2 circuits for another, these circuits are, guys, based on washing machines. How many washing machines did we have? 2. Now, when you go to the apartment, DJ, what would you expect this number to be? Big fat 0. When you go to the common area, common panel, what do you guys expect? No, hold the horses. These are on the common panel. When they go in the common panel, the house panel, what do you expect this number to be? 2. But the main panel, we'll see all of them. We'll see all of them. Okay? Then I want somebody to, then we add step 1, 2, and 3. You don't really need to do it this way. Step number 5, guys. 1, 3, 4. Step number 4 is just, you really don't have to write step number 4. It's just adding them up. And I made a mistake here, so can you guys add them up and give me the new number here? We need the new number. 29655. Anybody disagree with that? Did you guys come up with, the only difference is a 3 instead of 6? Right? Okay, good. So this is, I'm going to circle this number. I added them up together. And you guys are adding these because when I switch to the next page, I'll lose this. I'll take a snapshot of it and I will lose it. Okay? Okay, I want you to remember the number 29655, and somebody's going to give it to me. So I'm going to take a snapshot at this. I like to hear the snapshot. So make sure we got it here. Yep, it's a snapshot. It saved it. And then I will lose it here. So I'm going to start at this point right here. So I want you guys to get me give me the number that we came up with. What was the number that we came up? We carried from the top. 29,655. Thank you. That's carried over. Then I want you guys to go to table 220.42, please. Is it the right table? 220.42. 220.42 allows you to derate, because not everybody's going to be running their lights and receptacle at the same time, all the time, fully loaded. They allow you to have a derating factor. If you guys look at through it, dwelling units, the first 3,000, can you guys see that table? Everybody see the table? The first 3,000, do not mess with them. These are sacred cows. So what do? The first 3,000 out of the 29, leave them alone. This is leave alone, right? Anything larger than, so this number here, if you guys erase this number, this will be 29655 minus the 3,000. Anybody can give me the number here, please?
26,950.
How much?
26,955.
Okay, so you subtract 3,000 from it, and then and this will be carried also, this number will be 26, 9, 55, and then you multiply it by what? Multiply it by 35%.
That's actually wrong. It's 26,655. Yeah.
Okay. You're taking it easy on Chad. You start to sound like your teacher sometimes, guys. After only 6 weeks, imagine a whole year. All right, one more time. This one,
26. 655.
55, thank you. And this also will be carried as 26655. And you multiply it by 35%. Why 35%? Because the code says anything higher than 3 up to 120, you multiply. Am I at 120? Have I reached 120 to worry about other derating? I'm listed 120, so the only derating I worry about is 35. Anything higher than 120, you start cutting it by down to 25%. Okay, we're not there. So when you multiply the 35 by 26655, what did you get? This number here. 9329 volt amp.
Up or around that?
93.
9329.25.
0.25 round down. Yeah, anything 0.5 or higher goes up, less than 0.5 round down. Okay, and then what do we do? What do we do with these two? Add them up. Everybody can see that we add them up. That's a mistake that a lot of people do. So this becomes what? 96, and this is also 629, right? Volt amp. Did I do it right?
No. 12,329.
I calculated that. Okay, let's do it again. So 3,000 plus 93.
12,329.
12, 3, 29. Thank you. Volt amp. What am I looking? Talk about. Okay, so that's my calculated value. So what did I do, guys? I took all the stuff that I did so far and derate them. That's all I did. And derate them. I want you to highlight this number because that's a number that we're going to be carrying all the way down. That's a number that we're going to be carrying all the way down. Could you please highlight this number in a different color? That's the number that you're going to be carrying all the way down through the sheet. Why? Because it's already derated. It's already derated. Okay? Any question, guys, about that? Any question? Is it clear, guys? You have it in front of you. I have it on the board. We're going through it. That's basically what we're doing, guys, is chapter 10 and chapter 9 and 10. Literally. Chapter 9 and 10. Going step by step through it. Same, if you go read through the chapter, exactly the same. Okay. Any question up to this point? Please highlight this one in red. Why? Because we and Brad, since you're going to get 9 out of 10 in engagement and you want to move it to 10 out of 10, I want you to remind me later on as we carry this number down. Okay, we're going to move to the ranges now. Now we're done with the receptacles and lights and small appliances circuits and laundry circuits, right? Based on the code. We're going to move to other loads. Other loads. Okay, other loads. What other loads do we have in our building? Do we have, ask yourself, do I have a range, electric range? Yes, I do have electric range. Now remember, we're looking at the big picture, the main panel. Do you think the main panel is going to see the electrical range? Yes, it's a main panel. Okay, how many electrical ranges do we have? Do we have 5 or how many of them do we have? 4. I have 4 of them. I have 4 ranges and each one of them is multiplied and use a different color. And where do you get this? Who gave you this info? Uncle Chad? 4 times the info sheet that I gave you guys about the loads. What's the 8? I gave you that each one of these ranges is 8,000. Okay, and you multiply 4 by 8, you end up with 32,000. Anybody does not know why we end up with 32,000? Why 32,000? Because I'm looking at 4 ranges. Each one of these 4 ranges is 8. So 8 times 4, that will get you 32K, 32,000. Any question about that? Mr. Erbab, now, you're gonna go size the panel. Brooks, my friend, you're gonna size the panel for apartment number one. What do you think for apartment one? How many ranges do we have? 8K. Okay. Now, if you guys go to table, please go to table 220.55. Everybody has a table 220.55. If you have 8 ranges, all of them are number 8. So which column am I under? By the way, I assume, correct me if I'm wrong, I assume you have used this table before. Okay, this is not new. We used this table before. Okay, so I'm gonna go between 3.5 and 8 3/4. Right? Why did I go to B, column B? Why did I go to column B? It's 8, Chad, duh. And so what's then I need to add all of them, which is 32, and multiply them by a derating factor. How many of them do I have? 4. So my derating factor is 0.5. So multiplied by 0.5. Everybody knows why 0.5. I have 4 of them, right? Mr. Rebeb, we're 4 under column B. It gives you a derating factor of 50%. 50%, what does that mean? Add them up and slice them down by 50%. Now, here's my question for my friend Spencer. When we do the apartment, Spencer, what do you think we're going to have here? 8. One apartment number 1. And what do you think the derating factor would be for one range 8? Look at the one range. What? 80%. Thank you. Now let's go to pick on Muhammad, my friend. When I do the common panel, Muhammad, do I have range in the common panel? The house panel, the one that feeds the common area. Is there any range connected there? Anybody's cooking in the hallways or the stairways? No. So there's no common. So this number would be what? Big fat 0. Don't delete it for the common panel. But what do we do? What? Big fat 0. Am I clear? Am I clear? Say yes, Chad. What happened to your chicken hugging and all this good business? You're so quiet today.
Well,
I haven't seen anything. No emails coming here. A picture of a chicken or anything. You're so serious. I can't emphasize, guys. If you want to write yourself a note, when it comes to one range 8 from table 220.55, your multiplier will be 80%. And that will be for all panels. All panels except house panel. Right? Because why the house panel? Because the house panel has how many ranges? Big fat 0. Can you write this yourself a note? So as you develop your sheets, and you guys have a sheet, so you can write on it. As you develop the sheet, this will be a note that when you do.
Why is it 8?
What 8 ranges is?
No, we're doing one panel, one apartment panel.
One
So that's 8K, not
8.
8.
Oh yeah, 8K. I'm sorry, 8K. Oh, 8 would be small, huh? This is 8K. 8K, you go to table 220. Table 220.55 give you a derating factor of 8. What does that mean? You stick an 8 here and you slice it by 80%. Questions? Yes,
Yeah,
sir.
I have a question.
Yep.
When we're doing all 4 for the main panel or the common panel,
All 4 means the main panel
all 4 of the ranges
in the main panel.
in the main panel.
That's what we're doing.
Okay. There's a note 3 in underneath that table. It says over 1 3/4 through 8 3/4 kilowatts. In lieu of the method provided in column C, add the nameplate ratings of all household cooking appliances.
Yes, you can go check when simplify it, use B, but if you want to go use C to check and choose the one that gets you the highest demand, go ahead and do it. Absolutely. I just don't want to get into the 80 video calculation of it, but go use B. If you guys want to go check under C and C, which does C gives you higher demand, meaning smaller size, because that's cool for us because we size things smaller, use it. So for the most part, I want you guys to stick with column B. Any question? Because keep it simple. And so this number, who's my friend who's going to get 10 out of 10? Do I have friends in this town? Okay, I want you guys, this number will be carried all the way downstream. Anything that I square in red and I put these two stars in both sides, this means this stuff will be carried all the way downstream. All the way downstream. Because we're done with this step. Questions about ranges. If I have 100 ranges, the same thing. You're going to go to the calculation based on this table, which you guys have done it in the past. We're not going to go into the details of it. We can when we do the examples, but for the load calc, we're sticking with this. Moving into the electric loads dryer. Any question about the range? I can't emphasize. I want you to know what would you do when it comes to one apartment or the house apartment. House apartment, 0 for ranges. Common apartment, you size based on one range, 8K. Okay, dryers. Let's think about dryers. How many dryers do we have in this building? Decided to do in this project. 2 dryers. And the code, let's go to the code. The code is our friend. Can you guys go to this table here, 220.54? 220.54 code and table. 220.54 code and table. If you guys look at the code and table, this is also code 220.54. Their table and code. The code tells you if your nameplate is less than 5, use 5. Okay, and the table will give you a derating factor. Derating factor. So let's now. What's the number that I gave you guys in our project? 4. The size of the dryer. 5,000. I gave you a size of a dryer. Chad Curdy, gave you a size of a dryer of 5,000. Okay. So do I need to go up or down? 5,000. Stick with it. Had I given you a 4,000, what do you need to do? This number becomes 5. Okay. So I gave you a 5. Where did I give you a 5? In the sheet, guys, I gave you for the project, which should be right here. Sheet number 9 circled. If you look at the dryers, which I don't see, I see it says 5,000 at 240. Right from this information. Okay. We know where we got it. Let's discuss it again. The dryers are on the house panel. So when I'm doing calculation, first, how many of them do I have? 2. So what do I need to do with this number? Cross it, and there will be a 2. So 2 multiplied by 10, then this number would be what? It would be 2 times is 10,000. Chad. 10,000. Okay. Now let's go to the table for derating. 1 all the way up to 4. Can I derate 1 to 4? So my derating factor is 100%. Had you have an apartment downtown Minneapolis, and this apartment has 32-story apartment building, each one of them 32-story, you're going to need to go all the way to 220 to 54 and do some calculation for the derating factor. Okay. So everybody knows how to use this table. We'll use some examples in the table. Let me just say, if your dryers if you have 10 dryers, what's your derating factor from this table? 50. Okay. Can you guys see this table? When you go to 22 to 23, there's some monkeying around. Have you guys used this table, Gary? No? Okay. I'll give an example about the monkeying around with it. But for the time being, let's just continue with what it's really easy to use. But let's continue with the load calculation. Then we'll take a specific example about different scenarios of this table. Okay. So 2 times 10. Do I have to do it? What's my derating factor? And I want you guys to add a derating factor of 100%. So you remind yourself that the derating factor is 100%. Now, when it comes, now I know this is for the main big fat panel. When it comes to the common panel, how many dryers do I have fit from the common panel? 2. Yes, Bill, my friend. Oh. So how in the house panel? Are you guys following what I say? We have 6 panels. The main panel is I'm sizing right now. That's the one that feed everything. The main panel, the main service and the service entrance equipment, main panel. Then underneath it, I'm feeding 5 panels. 4 for the 4 apartments, and 1 for the house panel. Okay. So this calculation is for the main service entrance panel. When you do the house panel, this number would be still 2 of them, right? When I do the apartment panels, this number here would be 0. So do I need to, here you go. You design it one time and you just plug a 0 there. Any question? Any question, my friends? Okay, so I need my friend Holly to remember these numbers. Anything, guys, that I put like this, it will be, Mr. Urbab will be carried down all the way. Carried down all the way. Okay. Any question? So that's for electric clothes dryers. Can you guys see that I'm going through the loads, everything that I have in my building? Okay, let's go to step number 9. Electric furnace, air conditioning or heating pump, Article 440. And I want you to go to 220, the article that talks about non-coincidental load. Can you please add one thing? I want you to add an article here. It's 220.60. I want you to add this article. This is really cool. This article, 220.60. We don't have 220. We have table 220.15. So I want you to go to Article 2, 220.15. No, I don't have 220.15. That's from the old. So I want you to cross this and cross this. Okay? Can you guys do me a favor? Everybody cross them and go to 220.60. 220.60. Heating and cooling. This is called non-coincidental loads. Non-coincidental loads. Why non-coincidental loads? Highly unlikely that you're heating the building and cooling it at the same time, unless you're a knucklehead. Right? Highly unlikely that you're going to be cool and heat the building. So for cooling, for non-coincidental loads, and DJ, non-coincidental loads could be two pumps for redundancy. One pump is 30 and the other one is 30, and they're sitting in the same well house, and they're sitting there just for redundancy and for reliability. So if one pump's crap on you, you power the second pump. In this case, these are also called non-coincidental loads, right? They wouldn't run by design. They're not meant to run together. You interlock them. They interlock them electronically, where one will go and the other will not go. So in this case, that will be non-coincidental loads. In a residential building, guys, non-coincidental loads are mainly heat cool. You can't heat and cool the building, residential building or any building, for the most part, at the same time. Okay. So you need to go find the heat in your building and the cool in your building. I'm going to remind you guys, this is the general purpose heat, not the swimming pool heater. That's a special type of heating. This is a general purpose heat. What type of heat, guys, do we have in the general purpose heat in our building? We have the furnaces, and the furnace, by the way, the furnace itself, the blower of the furnace will work with both the heat and the cool. So that's out of the picture. Why? Because with the furnace has a blower in it. The blower, do you think in a central heating cooling system, the furnace will run with both? Get the furnace out of the picture. Furnace, blower. Then you're basically comparing the heating element, which is gas, out the picture, with the cooling element, which is the air conditioning that we have. So how many air conditioning do we have in our building? Our air conditioning, we have 4 of them. So that's where we come up with this number, guys. I have 4 of them. I have 4 multiplied by each one of them is 4,000. And that will get me directly to 16. I'm sorry, not 4. Yeah, 4 of them. 4 times 4 is 16. Yep, that will get me directly to 16. 4 times 4 is 16. Everybody knows why 4? What's the heating element? Where's the heating element that I'm comparing with? The heating element is gas. I'm heating the building with gas. None. Some of you guys might say, well, Chad, I have a few heaters, smaller heaters. I have a common stairway heater. I have a common stairway heater, one in every stairway. Okay, common stairway heater. You can think of them. Electric stairway heater. Let's do that right in here. So common stairway heaters. Stairway heater. If there's 3 stairways times 3K each, I gave it to you. That will give me 9 kVA. And then you are supposed to choose between 9 and 16. Which number is the largest? 9 or 16? 9. Do you think you're going to be heating the stairway while you are cooling the buildings? Of course not. So you're going to drop this calculation here, and you're going to stick with the largest calculation, which is air conditioning. Any question, guys? Any question? That's the only main heat, main. Why do you think I didn't put the swimming pool heater here? Swimming pool is not a general purpose heat, it's a specific purpose heat. Later on, Ryan, when we go to a commercial building and you have a cooling system that's dedicated for a data center, that cooling system is not, it will be running winter and summer to cool the equipment. That's not general purpose heating cooling system. Okay, so it's specialized system, leave it alone. These are general heat cool system in the building. Either you heat the building or you cool it. Any question, my friends? Now, my friend DJ, did you highlight that number that I'm going to be carrying? Anything with stars I'm going to be carrying all the way down? Any question? Did I hear yes, no? Guys. Can you please add another article to here? Because we're using heat. The article is 220 about fixed baseboard heaters, 220.51. 220.51. If you don't believe, Chad, when I did the calculation here, if 220.51, it tells you if you have a fixed in space heater, you take it at 100%, which we did them here, and then you compare the two of them. Any question? Oh, this one, 220.51. Yep, 220.51. Why did I add this one, Brooks? Because I had fixed in space heaters here, and I calculated them 9K, and I compared them with the 16K, and I picked the largest. Where did I get that 9K? That I need to include the 9K. Who told you to include the 9K, Chad? Duh. You're going to go to what? 220.51. It tells you take them at 100%. Can I derate these boys? No. Why can't I? Because 220.51 tells you though. The same thing here. 1600 volt amp. Brad, can I derate the 1600 volt amp? No. Why can't I? If you go to article 440, it tells you you cannot mess with them. What you see is what you get. If it's 100 kVA heat, it's 100 kVA heat. Leave them alone. But you can compare them with the heat cool and choose the largest. You can compare them with heat cool and choose the largest. Okay, I want somebody, guys, to carry these numbers so I can't when I go through, because I'm going to take a snapshot and move to the next. The next step, guys, is net computed general lighting, small appliances, laundry, range, ovens, blah blah blah. We're going to add what? We're going to add the step that's coming from lighting, the range, the dryer, and the heat cool system. We're going to add them up.
Which numbers are you gonna carry just,
Anything with 2 stars on both sides and red. And that's what we're doing in step 10. So you guys are gonna give me these numbers as we add them down, right? Okay, I want somebody to add them up.
54 and 329.
I need another gentleman or lady to agree.
That's right.
Okay? So I'm gonna go take a snapshot at it. Mr. Irbab, if I take a snapshot, it will disappear and put it on a different location. There you go. And then, see, we're going to go all the way to number 10. Number 10 here, number 10, my friends, it says, we're going to add, remember how I start these things, I put stars on them? Now, if my friend, I'm going to move it up slightly. For number 10, it says, add all these steps that we did, and the number that we came up with, I'm just going to minimize it all the way. Here's number 10, just to get the best out of it. So for number 10, guys, Holly, could you please give me the number again? So this number here, this number here would be
54, 329.
54, 329 volt amp. Did I get it right? Thank you. And this is step number 10. Remember, it's coming from the top and meaning add the 4 things that I highlighted. Are you guys following the trend? 5 minutes, you'll get a break, so don't sweat it too hard.
It says here you're supposed to put the general lighting in there, but then here it says add 6, 7, 8, and 9.
So add, okay,
Is the lighting in with it too, or?
we're gonna Can you guys give me the steps that we added here? Let's just erase this one. We added step
Well, that's 54,329 is just step 69.
6.
On the lighting.
We added a step number, the total step number
16,
5.
7, 8, and 9.
So we added 5, comma, and we added also
So we have 5 on there.
small appliances. No, that could be no, all the way. Actually, 6. We added 6. So this is right, 6, comma, and we went all the way to the range 7. We added 7, comma. We added 8, right, comma, and we added net computed. That's it. 8 net computed HVAC.
And 9.
And 9 for the furnace. Furnace. That's it. 6, 7, 8, and 9. These are the steps that we added. Yes.
What was the difference from you erasing?
Did I? Is that what it said?
That's what it said, yeah.
Well, it
Yeah,
says,
6D. That's the only thing is. I thought this is
60 takes into consideration your general lighting.
yeah. So we took 6D. Yeah, it's right.
oh, 6D, okay,
Yeah,
then.
right. I thought I carried something. Okay, 6D takes step D and one thing on step D. So that's right. Okay. Any question? Any questions so far? Any questions so far? Let's do the fasten in place appliances. And for this, I want you guys to refer to 220.52, Article 220.52. Can you go to Article 220.52? 220.52. It says, if you have, it shall be permissible to apply demand factor 75% on the nameplate rating of 4 or more. Only 4 or more. If you have less than 4, you cannot apply the demand factor.
That's 53.
What did you say? Is it 50? Yeah, 53.
You said 50.
But I circled 50. 220.53. Thank you. And fastened in place. It has to be fastened in place. Other than electric range, does not include electric range, dryers and space electric equipment and air conditioning. Why do you think they're not included? We already added them. Okay. And service in 1 and 2 family dwelling, only for residential. This calculation only for residential. Okay, so let's go look at the fastened in place appliances that we have. Let's look at the list that I gave you guys and see. Number 1, how many water heaters do I have? How many water heaters do I have? And what's the range that I gave you? 5. And how many water heaters do I have? 4. So what do you need to do with this number here? 4. And this number becomes what? 4 times 5 is what? 2, 0, 0, 0, 20. Okay? Let's go to the food disposal. How many food disposal do I have? And what's the size of the food disposal that I gave you? 1,000. I have 4 of them. 4 times, everybody knows what I'm doing here. 4 times 1,000 times 1,000 equal 4,000. Dishwasher. How many dishwashers do I have? Dishwasher, I have 1,600 volt M. Who gave you the 1,600? Where did these numbers came from? The 3rd Avenue jurisdiction. So 4, then you take the 4, you multiply the 4 by 1,600, and I will get this number. And then microwave. Did I give you a microwave?
You did.
I gave you a microwave.
Yeah,
1,000, yeah. Here's a 4 multiplied by 1,000, and the same thing. Furnaces. Now for furnaces, fixed in place appliances, heating. Furnaces heating. Furnaces is heating. This is the. I want you guys to get this out of the picture here, please. I don't want the furnaces. Because furnace is part of heat. Can you erase that? Okay? All right. Erase it. Why do you think I erased it? Because it's parts. It's gas, and I will add the blower into the motors. Blower has nothing to do with it. Okay. Can you guys add the number and give me that correct number here? And I need 2 gentlemen or 2 ladies, or a gentleman and lady. Huh? 34 4. What is it? 400. All 10. Anybody disagree?
Yeah.
Yeah.
38.
38. You guys wanna get
No, it's 30.
one more time?
34. 30 plus 10,400 is 34 plus.
Can you make up
34.
34.4? 34,400 volt amp. We need to bring another calculator here, guys. Okay. Now this number. Now, do I have? If you guys go to this article, step number 12, it says if you have 4 or more, you apply a demand factor of 75%. Spencer, does it say that? 75% demand factor. So you take this number here and you cut it by 34,400 and you cut it by 75%. Where did they get the 75%? From the article, and that will get you which number is here? Buddies, friends, friend to the end. How much? 25,800 volt amp. I need another lady or gentleman to approve. 25800. Okay. All right. So I want you now to put 2 stars next to this, because why do you think we're going to put 2 stars next to them? We're going to carry them all the way down. We're going to carry them all the way down with the calculation. Now let me, yes,
5 or 3 is it 25?
25800. It looks like a 3. That's 2. 25800. Okay. Any question, guys? All right. So now this number and this number, I'm going to add them in step number 13 and then give you a break. Okay. Step number 3 in total computing. You don't have to do it, guys, the same steps like I'm doing. You can do the add in different steps. Using all this stuff. So what was this number from step number 10, guys? That was a different number, I know. 54,329 plus, and I know this number is different. 25800, 25800, and this definitely will be different. Who's my friend is going to give me the answer? When you add these two together in step number 12. 80,129 volt amp. Now this is what we're going to carry. We're going to keep carrying this number now. See how we adding them, modifying them, carrying them? And we're going to stop for a break here. 5 minutes, and we'll continue when you guys come back.
Pause it.
Oh, pause. Thank you. And continue, guys. All right. So what happened to? Okay, great. Here's the number 80K for the most part. We're going to carry this 80K with a couple of other loads. Now, I got you guys into the commercial mood and industrial by adding motors. Motors, the article that talks about motors is actually article 430. 430, and in the NEC code book 220. So these, if you go to 220.50 and 430, it will tell you if you have motors, you're going to add. Here's how we do it for motors. You're going to take the largest motor, multiply it by 1.25, and then add all the other motors to it. That's what calculating for motors will get you. Okay, so let's go ahead and see what type of motors do we have. I have an exhaust fan. Is this right, guys? Do I have an exhaust fan? How many exhaust fans do I have? Laundry exhaust fan. I have one of them. Let me use the blue. DJ, did you steal the blue?
Yep.
No, okay. 1 times 1,000. That will get you 1,000. Sump pump. Sump pump. I gave you guys the volt amp for the sump pump. If you have the horsepower, you can get the horsepower from it. So swimming pool, washing, where's my sump pump? If Spencer, if they give you the horsepower for it, what do? From the horsepower and the tables in 430.250 or 248, most likely you can find the full load amp and multiply by the voltage. In this case, I already did that for you. So this is 1 times 1,000 equal the same. These are the same. Then bathroom exhaust fan. Bathroom exhaust fan, guys. Exhaust fans, laundry exhaust fan, furnace exhaust fan, motors. Okay, I give it to you 300. Did I give you bathroom exhaust fan? What's the volt amp for bathroom exhaust fan? Exhaust fan 300. So we'll erase this and put, how many of them do I have? 300. So 300, I have 4 times 300. This has to be a different number then. 4 times 3 is 1200, right? 1200. Did I do it right? Yep, volt amp. So correct that one. 4 times 300. And then the garage door opener. Garage ridge, where's my garage? Garage door opener. The garage door opener, guys, I give you half a horsepower motor. Half a horsepower motor. You're gonna go, I think we have 430 if it's a half horsepower. Let's go to 430, article 430 like we have done many times and find the full load current of this boy. Half a horsepower motor at 115 is 9.8. So for the motor, the garage door opener, here's how we calculate the garage door opener, guys. I'm going to write the garage door opener here. I have half horsepower. This is for the garage door opener. If you go to take this one to table 430.248.248, and what do you get the amps? Under which voltage? 120 volt. We're gonna find already here. So for a half horsepower at 120 volt, take it to table 430.248, and that will get you what's the amps? 9.8 amps. And then you multiply the 9 amps by 120, and what do you get? Close to 1200. Anybody has a calculator handy?
1176.
1176. Do I have 1176 here? Was it 1176? 1176. Okay, so I'm going to go here and put 1176 times, how many of them do I have? 4. Why 4? 4 stalls, right? Any question, guys? So that's finding the volt amp for a motor. And what's this number? What this number would be?
4704.
4704 volt amp. Now, I want to remind you guys, when we go, you have to ask yourself as you go through other panels. Let's ask this question. When I'm doing them, let's see which things is going to carry and which one would be 0 as we go through apartment panels. Do you have a laundry exhaust fan fit from the apartment panel? No. So this number will be multiplied by, instead of 1, you multiply by what? 0. 0 it. That's how, don't delete it. 0 it. So you say 1 times 100, but 0, nothing. And then sump pump. Do I have a sump pump fit from the apartment panel? No. Then 1 times 0. Bathroom exhaust fan. Do I have, how many bathroom exhaust fan do I have? In one apartment. 1. So that would be 1. Garage door opener. How many garage door opener do I have? 1. So this number will be 1. Do not delete things. Just put the 1 with the zeros. 0 if they're not there. Let's go for, okay, the pool pump. How did we come up with what we came up with? The pool pump, what did I tell you guys about the pool pump? Pool pump, 3 horsepower. Let's do the pool pump. For pool pump, 3 horsepower. This is pool pump. 3 horsepower, what's the voltage? 240, 240, right? You're gonna go to table 430 dot, I always forget, 430.248. 248, and the amp, you're gonna find the amps for this boy is what? 17, thank you. You're gonna find the 17 amp, and then you multiply this by the voltage 240, and what do you get? 40 80. 4080. Okay? Is that what you came up with here? 4080? We're going to delete this one and 40 or 40. We're going to have a 4080 times how many of them do I have? 1. And that should give me what? 4080. Okay. I need to add them all up, guys. Now down here, can you put total plus 125? Let's use a different color. This is 40. I want you guys to add a different color. Here it will be total plus 125% of largest. So I need to take the total plus 100% times of the largest. Looking at this motor, which one is the largest motor? The garage, no, single standalone motor, single motor, the pump, single motor, not single motor. Then when you do this step, here's what you're going to do. You're going to take 1.25 times, what's the largest motor? Full pump, which is 4080, plus all the others, plus basically this one, and this one. Don't add the pool pump again. So how am I going to do that? I want to say here, I want to call these A, B, C, D, and then E. And I'm going to say plus A, B, C, D. That's it. Would that make it clear, guys? So what I did, I took the largest motor, which happened to be the pump, up it by 25%, and then add step A, B, C, and D to it. And that would be the number that you guys are going to have right in here. Who's going to give me that number? Anybody came up with that number?
13,004.
Let's put it here. 13,004.
13.
Oh. 13004. Okay, everybody came up with that number? Okay. So let me just put it, so 13004. So I want to put the number in here. Right in here. 13004 volt amp. 13004 volt amp. Okay. We all know that some of this stuff will disappear as we go through the panel, filtered, other panels. Let's go to the other loads. Other loads, if you have other loads that's not accounted for, guys, in this case, I have a pool heater. And my pool heater happens to be, from, what was the 220 dot, talks about fixed in place heaters. The closest that you can find to it, 220.51. You can put for the pool heater, guys, here, in this case, 220.51. I have one pool heater, I gave it to you, right? and that heater is running at 4K, 240. 4K, 240, that will give you 4K. So you need to highlight this 4K and put stars next to them so they can carry the same thing here and the same thing like this here. Okay? If you have other loads, we can add the other loads here. So the article for this, the pool heater is 220-51, meaning add it as is, don't derate. Now I want to remind you guys, as you do this for an apartment, you're going to use, as you do it for the apartment, you're going to use the largest cooling or heating, and you can always end up in cooling. So what do you think, when it comes to the apartment, what do you think this number would be? Apartment panel? Zero. Okay, we're done. Believe it or not, done. I want to add another step here, guys. I want to call this step I'm going to call it, just for the lack of a better name, 4.2. 4.2. I want to say add. What are we going to add? What's the step before that one? Was it before 14? Was it 13? Add 13 plus 14 plus 14.1. So when you add these together, what do you get? You're going to add this number to this number to the 4,000 number. Right? These are, because this number carries everything at the top. What do you guys come up with? Brad? Don't use your brain. We have calculators.
97,133.
Okay, what, one more time? 97,
133.
133. Anybody disagree? Dare to disagree? Like to disagree? Care to disagree? No? Okay. 97133. That's it. That's a total. That's everything that's going to be fit from this apartment. Everything that's going to be fit from this apartment. Have we forgotten anything, guys? We accommodated everything in the whole building as a whole. Okay? All right. Then minimum and any question, guys, up to this point. So that's the number that you're going to live by. I'm going to highlight it again because that's the most important number. That's all. We captured every single load in this building. We captured every single load in this building. Okay, let's go then. But if you give this one to Callahan and say, give me a panel for this, they'll look at you and say, where are you coming from? We don't talk volt amps. Remember, this is the unit for this is volt amp. We don't talk volt amp. We need amp. How do you convert a volt amp into amp, and what's your voltage system? My voltage system is 240/120. So I need to carry line, this is line 14, a minimum ampacity for underground conductor. Can you guys change this one into 14.2? What was 14.2? 97,133. So I captured this in a cell, 97,133 in Excel, divided by 240. Why 240? System is 240. Here's my question for you, Chanel, my friend. If my system was 208 three-phase, you divide this by 208, and don't forget to multiply by what? 1.73. Okay, so that will get you, you divide all this together, divide these two numbers. So you're going to, basically, what you're doing is you're taking 97,133 divided by 24. You do this in the brain of, in Excel sheet, and what do you get? What do you get, guys? I'm going to erase this one here. And what do you get as an M? No, I'm sorry. I need this. And then we size the panel. Actually, I want to erase this one. I erase it. What do you get instead of this? And here, what's the M that you get? 404. 404. 405 M. 405 M. Did we did everything, guys? 405 M. 405 M. 405 M.
How do you factor in landscape lighting? It doesn't go in a general lighting road, does it?
No, no. Technically, when we go to the commercial building, we start adding another parking lot lights and landscape lights. In residential building, technically we should add it somewhere. If you want, add it under a landscape light and just add it as is.
Continue.
Yeah,
Okay. Just add
Just
1500 volt amp.
non-continuous
or
in residential. Yeah,
another circuit.
just another circuit.
Okay.
So if you want to count it.
Even if it's.
Not everybody did it in our example, so we didn't put it, but technically, yes, you add it. You add it as a separate line and keep it, add all of it.
It's not, it's so little too.
In the scheme of things, it might not make a difference, but technically we can add it. Okay, 405. Then guys, we need to size the panel. I want you to add 16.1 panel, or maybe, I think we have it down, let me see, I think we have it down at the end. We do the neutral now, and we have it down at the end. Minimum viscosity, service entrance. We have it last at the end. I see raceway size, grounding, neutral, ungrounded, size conductor. No, so I want you guys to add right here 16.1 and see panel size. Panel size. And for panel size, and next to it say over current protection device. Okay, so and you're going to go to which table? 240.6. So go to 240.6. But before you do that though, did I tell you guys to add future expansion on this building? You guys remember the future expansion that Chad, now that's Chad opinion. Did they tell you to add future expansion on the feeders? If you look at the future expansion, if you look at the future expansion that we said we are going to add, anybody found it? 15% on the main panel. And that would be growth, yeah, that would be in page 2 circled. It says allow 15% additional growth on the main panel. Now, this is opinion up to this point. Opinion. You can decide to allow 5%, 2%, 3%, but let's just follow, guys. Now, up to this point is opinion. So before I actually size my panel, I'm going to go and add future. I'm going to call it here. I'm going to call it 16.1. I keep calling it future expansion. Future expansion. Opinion. Please remember, it's opinion. So I'm going to take the 405, multiply it by 1.15, and I'm going to say 15% next to it. 15%. 15%. Okay. And what would that give you? How much? 466 amps. 466 amps. Future expansion. Now I captured the future expansion. Now, Brooks, at this point, you can throw the 16.1 step if you don't want to have the future expansion. Okay, future expansion. And then I'm going to call, where am I going to make this step that you guys don't forget it? I'm going to capture this step that's underneath it, 16.2, and I'm going to call this one panel size, and I'm going to make it panel size and over current protection device size, 240.6. Now go to 240.6 and size me the over current protection device. Why is this came all the way here? Okay, that's 6. How much?
500?
500. 500.
And that would be for the main panel, right?
That will be your main panel.
500 amp.
This is separate here. Separate them. Okay, so what size panel do I have then for this building? We size it for you, 500. 500 amp. Any question, guys, about this? Any question about this? 500 amp panel. Now we're going to go size the conductors for it later, but stick with that number and let's go continue sizing the neutral. We're going to go step number 17, guys, has nothing to do with what we've done so far. Just we're going to go to the neutral. We're going to go size the neutral.
Let's start, 16.2, what's the red thing? What's it say? 16.2.
16.2, it's the panel size. Panel size. Panel size. Panel size. Running out of room. Okay, I'm going to capture this. Did I capture it? I don't want to capture it twice. I'm confused. Yeah, we capture. Yeah.
Why do we use 240.6 to size our panel? Isn't that circuit breakers, not panel size?
You have a great point. Let me just delete this one and capture this one before. Oh, don't tell me that I lost it.
You lost it.
Lost that? Oh, shoot.
You have to do a smaller one.
There's no. Okay. Ah, got it. Okay. Okay. Now we capture. The question is, my friend Brad said, why did it go to 240.6? Panels, guys, are sized based on two things. Number one, the bus size inside the panel, which is from our friends in DeWalt. But the code says the size of the panel is based on the size of the overcurrent protection device that protects it. For example, if this panel was 200 amp panel, bus-wise, cover inside it, and I decided, Chad Curry, single-handedly to throw 120 amp ahead of it, this panel code-wise becomes 125 amp panel. The overcurrent protection device, the main overcurrent protection device of the panel decided the code size of a panel. Does that make sense? So that's why I went directly to 240.6. My panel could be 600 amp panel, right? Do we have a 500 amp panel, single phase? We don't. So the actual size of a panel would be 600 amp panel, but my overcurrent protection device inside it would be what? 500. Is this okay? No problem. I can put 400 in there. I don't want to get into sizing the panel. The actual panel doesn't sell the commercial, but for the time being, stick with the size of the panel is the size of the overcurrent protection device exactly based on the code. Okay, let's guys go ahead and and size the neutral. Now for my neutral, I want you guys to go to 220.22. That must be from the old code book, absolutely. Where's the, it says about neutral, dwelling, 220 dot, not optional, feeder service, neutral load, 220.61 is the only, we're gonna do the 220.61. We're gonna go to a few articles here, guys, as we go through, but for the time being, I want you to erase this and put 220.61. Sizing the neutral. Okay, let's go size the neutral. When we size the neutral, two things. Number one, anything 240, what do you do with most of the things that's 240? Out the window. Out the window. So 220.61, all the article. If you guys go to, what's line 6? Line 6, do you remember that line 6? That's, what was the line 6? Can anybody give me line 6? Line 6, the new line 6. New line 6, what is it? 12,329, right? Is that line 6 that we got? Okay, so that's line 6. Then line 7. Line 7, guys. What was line 7? I just make sure. Was it 1600? That's what is it? What this talks about line 7?
16,000.
I know. What is it about? This range?
Ranges.
Ranges. It says ranges. If you guys read through 220.61a, it tells you if you have a range, add all the ranges, and you can cut the neutral. You can cut their neutral by. You can cut their neutral by 70%. But here's the. I don't want you to get. This is range. I want you to get the number here. What was the derated number for the range? The derated number.
10,000.
Because 4 of them we cut them by half. The derated number for the range,
Yep.
the one that we derated, right, was 10. 10. Which was step? What was the derated number of the range
16,000.
16.
Because there's only 4.
for ranges? For ranges,
So
I
we-
no
So we derated by
0.5. We derated for 0.5.
You had four,
16,000 is that.
you had 4 of them at 8,000, you derated by 0.5, you got 16.
Yep. So let's go back again to the neutral, back to the drawing table. This, I'm sorry, I lost my mind lost it a long time ago. Okay, let's just give me that. Or is it 220 dot? This is 220.61. I want to go to this was I'm sorry, one more time. Chanel. A 12,329 volt amp. Okay, and then let's go to 7 is
16,000.
ranges. Ranges. How many do we have? 8 of them.
4 of them,
4 of them. 4 times 8.
32.
32, we derated them to 16. So this number is already the derated value. That's a key point. This number has to be the derated value. The derated value. So 60, right? Is that okay? 60 multiplied by 0.7, that's okay then, right? Then let's go to number 8. What was number 8?
10,000.
0.7, because the code says you can direct the neutral again 0.7.
10,000.
For number 8, derated for dryers, right? Dryers, did we derate? No, so that was before it was 10,000. This number was 10,000. If you derate this one by 10,000, what do you get? 7,000. Okay? That's it. That's basically the 2 steps that we grabbed. The 2 steps that we grabbed. Okay. So we captured these. Then we're going to capture anything 240 is going to go what? Out the window. Anything 240 guys going to go out the window. Okay. Let's line include volt 120 only. Line 11. Let's look at the pool pump. Was the pool pump 220 or 240? The pool pump 240. So what do you need to go with this? Cross that one. Okay, food waste disposal, dishwasher, bathroom, exhaust fan, garage door opener, and microwave. I'm going to put these guys. This is, I want to say A, B, C, D, and E. And I want you guys to give me, are these for the garbage disposal were right? For dishwasher, we're right? Bathroom fan, right? There was a garage door opener was, I think we corrected it. What was the correction for the garage door opener?
1176.
Exhaust.
Garage door opener,
1176.
1176. And microwave, still the same.
Exhaust fans and office fan.
Oh.
300.
Exhaust fans, we have an exhaust fans.
So it should be 12.
This is, yep, thank you, 300.
300.
This became 1200. right? 1200. Did we correct anything else or missed anything? Did we account the garage door opener? Anything that's 120? Remember, are we missing anything 120?
Just change the door opener code.
Garage door. Oh yeah, thank you. What was that? We thank you, my friend.
4704.
4704. Thank you. Everything else stays cool. Okay. All right. So then, which one of these is fixed in place appliances? So we can apply the demand factor of 0.75. So I'm going to say here fixed in place.
Microwave.
Okay, A, that was an A, and dishwasher B, and C, no, D, no, microwave E. Are you guys with me? A, B, and E are fixed in place appliances. So, right?
Isn't the exhaust fan?
Exhaust fan is motors. We put them under motors. Okay? So with this, these A, B, and C, or A, B, and E, what do I need to do? I'm going to add them up and multiply them by 0.75 because they're fixed in place appliances. So could you please, under these, add, how many see? A, B, and C, add them up and give me the answer for A, B, and C. Only A, B, and C. A, B, and C. 1404.
No,
Is it C or
400.
A, B, and
14,400, sorry.
E.
14,400.
14,400. Right? Anybody disagree with my friend?
I just have a question.
Yeah.
You said that you were gonna multiply by 0.75.
Yep.
Where in the code does it say?
Ah, that's a fixed in place appliances. 220.53. 220.53. Exactly, guys, like the hot conductor. Exactly like the hot conductor.
I guess I thought that we already did that.
Yeah, we did it. We did this calculation, guys. Let me repeat myself. The calculation that we did is to size the phase conductors. Now we're going to do the same calculation to size the neutral conductor. The same calculation with some modification. That's what we're doing. The neutral is allowed to use the same calculation except with modification. Here's modification number one. For the range and the dryer, they allow you to cut them by 70%. For everything else stays the same. Anything 240, what happened to the 240? Out the window. Okay, so I'm going to multiply this one by what then? 0.75. Everybody knows where 0.75 came from, and what do you get?
That A, B, and E, or A, B, and C?
A, B, and E. That E is not sticking here. Comma, E. A, B, and E. 10,800 volt amp. Great. Okay, cool. Now, the rest of them, I need to add them. No derating. What's the rest of them? The one that, the motors. This one and this one. These two. So underneath it, guys, I want to say this is fixed, and then the other one is motors. Motors. And I'm going to add which one this time? Motors, add C and D. C, comma, D. Add C and D. That's just add them and give me the answer right in here. Add C and D. 5904. 5904. 5904. You guys are cooler than grandma. 5904.
Was the new, rate under 220, maybe between under 220, yeah.
Motors.
Okay.
Motors, add CD
Okay.
and give you 5904. Now, what do you think? We're done. What do you think? We'll add them up. and divide them by the voltage. So we're gonna go add them up. So we're gonna say, the other thing that we need to do, guys, on motors is we actually, we're gonna multiply by 125%, the largest motor. Now looking at these, which one is the largest motor between the two motors? Just the motor. 47, right? For as an individual motor. Oh man, that will. Okay. Let me just say for motors. I'm going to do motors here. Motors, you guys do it this way. You take 1.25 times the largest motor, which is 1176, plus all the other motors. What's the other motors? 3 times 1176 plus 1200, 12,000, right? Is that 100, 1200? This is 1200. It's getting ugly here. 1200. 1200. So this is 1200. Let me just tell you what I'm doing here. And find me the answer. And I'm going to erase the motor from right in here. That's how you do the step for the motor. And why, I'm going to explain in a second. For motors, guys, you take the largest motor among all these motors, all the motors, add 25% of it. The leftover is three garage doors, a leftover, because there's another 3, multiply by the same, and then add all that was the bathroom exhaust fan. What do you get? Do you guys get that one? It's not going to make a whole big of a difference, guys.
28, 23.
28, 23. All 10. Then, anybody came up with something different? I should wait until 2 gentlemen, 2 ladies agree. Okay. How much? $61.98. Okay. Now here's what we need to add. I need to add this number to this number to this number to this number, and don't forget also these numbers. I need to add all these numbers together. And that will give me my neutral. Should give me my neutral. I want to add the 6198 to 12,329 to the 11,200.
Yeah, 47.5.
Did we correct this, by the way? Did we correct this, guys? What's number 8 again? Can you give me number 8, please?
Number 8 is 7,000.
Number 8 is 7,000. Okay, yep, that's corrected. 7,000.
Yeah, 47.5.
How much?
47,527.
36,327.
What do you get?
Okay, now we have 2 gentlemen agrees on 2 different things at the same time.
I got 30,60,27.
Okay, let me take.
Because there's
23,
three values of 10 there. And then 6, and then 6, 7, and 2 is 15 right there, so that's 45 right there.
What do you
We're
get?
seeing 30,000.
We're adding 1, 2, 3, 4,
47,
5.
47,
Agree the values over 10,000.
6 and 7 is 13, plus 12 is 25, plus 10 is 35.
Plus
Where's
11,
7, 5,
plus 11, 2.
where is 11 2 at?
11, 2. It's for step 7.
It's 47.
Okay, now you guys got it?
What is it?
47, 5.
We're coming here.
47, what?
We're gonna add them. I'm coming to add, we cut this step. I'm going down all the way to this step. Okay, what was it? Right here.
47,500.
What else
One
are
sec.
we adding you?
Okay, here you go. I'll go back, no problem. Here's what we're adding, guys. Here's the stuff that we added.
I think that we should just roll a full sentence.
That's a good idea. Did you guys get the stuff though?
Yes.
Here's what we're adding. 1, 2, 3, 4, 5. Yes.
I'm just a question.
Mhm.
Are we throwing out all the ones that are 240 because there's
Because-
no current on the
Yeah, there's no
neutral
current in the
rate?
neutral. They're balanced. The reason why we added the range and it has 240 because the range has loads at 120 and loads 240. The dryer the same way. Anything that has 240, 120, you add it and you derate it by 70% because 70% of the load is non-120. They assume. Okay, let's let's go back to our sheet. Line total D. This one, guys, I already included it. This step, I already included this step in the calculation before. Largest motor, I already included this largest motor. Adding all the above, adding all the above, what did we, this is what you guys added. Can you give me the total from which line? Total. That would be, because we mixed them up, that would be total from 7, 8, and 11. That would be total. 7, can you write them down? 7, 8, 11. 7, 8, 11. And then, huh?
6, 7, 8 equals 11. So I just took the
Line
line 11.
11. Okay. Line 11. So from the step before, I want to carry this number. Add them all up. We said we did this. We did the largest motor and add them all up. And that, what was the number that you guys came up with here? After we had all of them.
47,527.
The step, just the step before, 500.
No,
And
47,527.
47,527. That's the step that all the stuff that we did above. Then you're going to take this 147,527. What's the amp? Divided by 240. Yep. 98.
198.
198 amp. 198 amp. Future expansion. Remember the future expansion? 120 because the load is going to be balanced between the two 120s. Future expansion. This is Chad's 15%. So 1.15 times 198. What do you guys get?
228.
228 amps. 228 amps. Questions?
Yeah, give me just a second.
Okay. The reason why I deleted this stuff because we already did them at the top.
What was line E? That was
The lines,
we said you get the 400.
Okay, let me go back. Here's what we added to come up with the numbers, guys. We added this number, which was for motors. Shall we number them?
There was a 5,904 figure in there somewhere, but I'm trying to figure out why I have that written down.
Oh, yeah, that's because I figured it out too. I had it.
We have, guys, we took.
But this line E number is this 47,527?
Okay,
Is that what
let
it
me
is?
put. Can you guys go back to this sheet that you were in, and let's just give it different. Adjust the names. Just adjust the names. I'm gonna call this one. I'm gonna call the motors. This will be number 1. This value that you got here is number 1. This value that we got here is still
I understand.
number 2. This is number 2. This value here. The value is number 3. The 700 is number. So this is for this. This is for this, and this is number 4. Are you guys with me? This value, which end up here, that's I called it number 1. This value, which is this value here, is number 2. Number 3 is 11200. Number 4 is the 700, and the last one, number 5, is fixed in place appliances. Fixed in place appliances give us that number here. Okay? Do we agree what we're adding? We're adding number 1 that gives me this number. Number 2 that gives me this number. 3, 4, and 5. Okay? From this step, can you guys adjust it? Adjust your steps. 1, 2, 3, 4, 5. These are what we're adding.
And that gives you this line E number.
And then now going back to my going back to now I lost my that will be line all this instead of this, guys. Oops. Oh no, don't die on me. Instead of all this, I'm going to say 1, 2, 3, 4, and 5. And can you please give me, these are 1, 2, 3, 4, and 5. Can you guys give me this number, please? We canceled all the 37, 5. 47, 5, 27 here. And when we carried this one here, 47, 5, 27, came up with 198.
198.
Thank you, 198 amp.
With your additional.
And then we put future expansion, 15%. So 1.15 times. I wrote this one, guys. Don't write it. It's just for the PDF here. And that will give me what? 198. That will give me 228 amps. Thank you, my friends. 228 amps. Almost done. Almost done. I know your lunch is coming. Almost done, guys. The rest is just going and sizing cables, and which is you are very smart at doing that one. 228 amps. 228 amps. Okay.
So if we threw the 240 out when we were doing our calculations, where are we paying by 240 and not 120?
Very good. Very good question. Because the load is going to be balanced between the two phases, right? Half of these 120, or close to half, will be in hot 1. The other half will be in hot 2. You're not going to put all of them in hot 1, are you? You can't, even if you want to. If you start loading them on any side, you start balancing. Because they're balanced. Yes, they're 120, but they're balanced between the two of them. Okay, so 228, good question. 228. I'm going to add one more step, guys, from article, and then 220 to 61. Can you write it right here? From 220.61, anything higher than 200, I have for neutral. 228 The first 200, leave them alone. Anything higher than 200, what's the anything than 200? 28, multiply this by 0.7 again. If you guys look 220, 220, the feeder, 220 dot a B, also a B here. 220.61b tells you anything higher, the first 200, leave them alone. Anything higher than 200, cut them by 0.7. So what's the answer? So 200 plus 28 times 0.7, 220, 220 amps. And that will be the size of your neutral. If you guys highlight this one, love it, do whatever you want to do with it. This will be the size of your neutral. That will be the size of your neutral. Okay, the last thing, guys. So we have an amp to size the neutral, an amp to size the hots. Now we're going to go find conductors. Just conductors and conduits. Conductors and conduits. Conductors and conduits. Okay? We're going to size conductors and conduits. We're going to go size our conductors and conduits. I want somebody, guys, to remind me. We came up, what's the size of the panel that we came up with? 500 amp panel. And what's the neutral? 220. Okay, I'm going to go back and size the cables now. All the way to the cable. That's it, done. I promise. Now, we're going to go to the table. Can I use 310.15b6 anymore? What is the limitation of 310.16b6? This table here, what's the limitation of this table? 400. I exceeded 400. What do I need to do then? 310.16. You need to go to 310.16. Okay, for 310.16, guys, I have 500 amp, and I need to size it. What size you can get? I'm gonna erase this one here and just come up with a size. What's 500 kcm from 310.16? 310.16. How many conductors under 75? How many conductors and what size? Let's just pull one conductor. 600 or more than that? 900? Too bad. I want a parallel. I want a parallel. Let's go parallel. Let's take the first 500 divide by 2 equal 250. Take this one to 310.16 under 75-degree column. What do you get? Here's what your answer should be. 2 sets of how many conductor? 250s. Two of how many conductor? 2 conductor. 250 kcm. Here's the size. 2 sets of 2 conductors, 250 kcm each. Not clear? 2 sets.
Hey, I thought we were.
Yeah.
Yeah.
2 conductors.
Underground.
Number 250 kcm. I'm going to write them here and then erase what I wrote here, and I'll answer my friends who are yelling at me from the back here. Okay. Gentlemen, if you look at where I am right now, what am I sizing here? Ungrounded conductor. We will come to the neutral. We will come to sizing a neutral underneath it. See? The next step is a neutral. Guys, we found the amps. We found the amps first for the panel. I went and I sized that. You can arrange them any way you want. I find the conductors for the ungrounded conductors. Then we need to go find the neutral now.
Says 500 amp panel.
It's a 500 amp panel, right?
Alright.
So we divided by 2 to parallel, and we parallel 2 sets. Now for the neutral, guys, for the neutral, the amp for the neutral, what was the amp for the neutral? 220 amp. and here's the size where the neutral is going to be. I'm going to do the calculation here. Take the 220. I need to parallel. Why do I need to parallel? Because I parallel where? 2. That will give me 110 amp. Take this one to 310.16 on the 75-degree column. What do you get? One conductor. How many sets first? 2 sets. 2 sets. And one conductor. Each one of them is what? Number 2. Number 2. Now there's a little problem here. You can't parallel less than 1 aught. You can't parallel less than 1 aught. There's a little problem here. The calculation came up with number 2, except you cannot parallel less than 1 aught. Okay? You can't parallel less than 1 aught. So what's your calculation? And I'll find the article for you guys. Anybody can go get me there?
310s,
Is it 310?
310.4.
Wow, you're good. 310.4. Conductor parallel 310.4a. You are cool. You got your 9 out of 10. 310.4. For a second, I missed it. So if you guys go to 310.4a, it will tell you cannot parallel less than 1 aught. So the conductor here, then we scratch this and it becomes 2 sets of what? 1 conductor. Come on. So electrical association. Go. 1 aught. Okay, done. Any question is, we size the neutral, we size the phase. So why 2 conductors? Because 2 hots. We size the neutral. Now, for the neutral, Brooks, a lot of people will say full neutral and color ID. So you can size full neutral if you want to. If you don't want to size full neutral, you size it based on this calculation. Okay? One last thing, and then I'll let you guys go. I'm not going to do the conduit fill because you guys are smart. You can do it. Your lunch is going to be long today, huh? Okay, Holly, capture all these numbers for me. You capture them. We're just going to do, we're done, guys. See, that's it. I just want to do the grounding electrode conductor. For grounding electrode conductor, you're going to go to 250.66, table 250.66. I'm sizing the grounding electrode conductor. 250.66. If you go to the grounding electrode conductor, here's what it tells you. Everybody knows what the grounding electrode conductor, the one going from the ground rod all the way to your building. I parallel. So here's what it says. Take the service. How many conductors do I have? 2 runs. Each one of them was 250, right? KCM. That will get you 500 KCM, right? Take the 500 KCM, take it to table 250.66, and that will get you 1 conductor, 1 aught. There are some exceptions. You don't need to go higher than number 6 if you're going to a ground rod. For the most part, that's how you size it.
Because it's the whole system, we have to go back to 500.
Yes, because we ran 2 sets. You go, if you go to the table, it goes by size of conductor. But what happens if you parallel? Huh? 2?
I think that's the aluminum.
2. Did you look at the aluminum? We're in the copper. 1 aught.
350 to 600 in copper is 1 aught.
When are we? Are we missing a point here? What?
No.
Okay. The last thing you guys are gonna do, I'm not gonna do it. The last thing you're gonna do, you're gonna find the conduit.
Oh, wait,
Is that?
it's 250 through 500 would be number 2. copper. Over 3 through 350.
Over 350, 600, copper is.
I have 500.
Under the copper,
Okay, 250. That.
over 3 through. Oh no, that's right. I'm reading it wrong.
350.
Through 600.
600.
Copper.
Yeah, why not?
Yeah,
What's
I
wrong
was
with you?
reading it wrong.
Okay, guys, we need to go eat for Pete's sake here. Okay, let's keep moving here. Ah, Chad. Okay. Then the last thing, promise, last. We're bringing conduits. What type? From the underground. PVC Schedule 80. So change this one into PVC Schedule 80. Now, question for you guys: when you do the panels inside the building, you're going to use what? EMT. So this is going to change. And how many conductors are used? 250 here. How many conductors for them? I use 2. So I'm going to change this one. And what was my neutral size? My neutral size was 1 knot. So this one, you don't need this step here. 1 knot for my neutral. And then you're going to find this calculation and you guys are going to size it. You know how to size. All these are different. These values you're going to adjust them. So what I'm doing, guys, I have 250 kcm. I need to find 2 of them. I need to find the cross-section area. You'll find it from where? From table chapter 9 and the appropriate table. Table 4, chapter 9, table 4 and 5. You need to use table 9, 4 and 5. And then you do the calculation and you size your PVC. Size a PVC conduit for 3 conductors. Do you guys know how to do it? 3 conductors. Then how many, remember, each conduit is going to have 3 conductors, 250 each. But we're going to have 2 conduits. Does that make sense? When we parallel them, here's how it's going to look like, my friends. For crying out loud here. Here, here's one. Here's the second hot. Oops, here. I wanted to be, oops. I wanted it to be different color. Here you go. Here you go. Okay. So here's to conduct and we have a neutral, and my neutral is right in here. So PVC Schedule 80. We're paralleling PVC Schedule 80.
So you have one 250 kcm in each of those.
Yep.
And you have one knot in each of those.
One knot. No, the equipment grounding conductor has nothing to do with it. This is here. Let's just see what's in. These 2 guys, there will be 2 number 250 kcm. The neutral will be 1 conductor number 1 knot. Done. The equipment grounding conductor will not be in the conduit. The equipment grounding conductor, that's just a wire going all the way to Mother Earth through a ground rod. Though, when we size panels, the equipment, the grounding electrode conductor will change into what when we size the inside panels? That convert into what? Equipment grounding conductor. So this calculation is right for the main. When we do it for the sub panels, it becomes equipment grounding conductor. You're going to go to a different table, and I can help you with that, which is 250.122. Huh?
Based on overcurrent.
Based on overcomputation device. Done. This is as ugly as it gets, guys. You have the sheet in front of you. I'll put the PDF file on the network. You have this recorded, if that will help.
You go back to
Uh,
the last one.
I'm sorry.
You go back to
The last.
Yes. Because we didn't that example that we didn't cross out. In the example.
Yeah.
Can I, like, so we can figure out what his question is? In your example, before we crossed everything out over it.
Yep.
So your calculations on here, when you started, you had, your
Let me just
underground
turn the-
conductor size was 600 kCF.